All right, so now we move on to lesson 6 of equations, and that's word problems. So word problems are saying, how can we take something that is in context of verbal words or a sentence or a paragraph and then say, okay, let's dissect that and then make an equation and then solve for whatever unknown that they're talking about within that given sentence structure. Well, here's how we do this. So how to solve word problems. We need to read the question and determine what type of keywords are going on. So things like how many, what is, how long, how much, determine. These are those key words that you need to look within the sentence. Then, oftentimes, what they'll do is take those keywords and associate them with a specific thing that they're referring to that they want you to find. And this could be things like money, papers, lengths, dimensions, how long it will take in terms of time. And then we look at, once we know the descriptive words or specific keywords, we know the words that are associated with those keywords, we need to let a variable represent whatever unknown we have. So we can assign a letter, and realistically any letter, to any given unknown as a way to help us solve the problem. Then what we want to do is assign units to our variables. So if it's in centimeters, we should know that it's in centimeters. If it's inches or if it's millimeters or whatever it is, or if it's dollars, we need to define our variable in terms of what it needs to be equal to. Then we want to see if there's more than one unknown. So there may be a relationship to the given unknowns if there's more than one. We want to write down any known quantities, and then finally we want to check our answer once we know the specific quantity for any variable. And then finally, if we haven't clearly defined our statement yet or clearly defined our answer, we need to do that right at the end, and we need to include our units. So if the answer is asking for some unknown in dollars, we need to include those dollars. If it's including it in terms of a measurement like centimeters, we need to include centimeters at the end. Okay, so let's take a couple looks at a couple problems that clearly outline this process here. So in example 1, they say that John is 3 years older than Jim. Jim is 4 years less than twice David's age. How old are the 3 boys if their ages add up to a sum of 35? Well, there's a couple things to pull from this problem right away. Well, we have 3 people, John, Jim, and David. And specifically what's going on here, John is 3 years older than Jim. Jim is 4 years less than twice David's age. Well, the one that we don't know for sure and that has no comparable descriptors is David's age. So what we're going to do is we can actually say, let David's age be the unknown, or specifically just the x by itself. We were given the description that Jim is 2 times minus 4 in comparison to David's age. So he's 2 times David's age minus 4 years. And then John's age, we get a description right at the beginning. In a comparison to Jim, John is 3 years older than Jim, meaning whatever Jim's age was, we need to add a 3 to it. Okay, and then finally, they say that the sum of all 3 of these brothers, David, Jim, and John, should sum to make 35. So what we're going to do is we're going to take our x, 2x minus 4, and then 2x minus 4 plus 3, and we're going to put them all together in a statement where they're being added and equal to 35. If I collect the like terms, I realize I have 5 x terms. I have 1, 2, 3, 4, 5. And I have negative 4 minus another 4 plus 3, which I will then collect and move on to the one side. And then finally, I can isolate for x. So what does this tell me? Well, x being equal to 8, that actually tells me it's David's age, because David's age was symbolic by just the x alone. Then I put in that x equals 8 for the following, and this symbolizes Jim's age because we knew it was 2x minus 4. So we have David's age, which is 8, Jim's age, which is 12, and then finally I plug in that 8 for this final line, and it's symbolic of John's age. And when we do John's age calculation with 8 in for x, we get an age of 15. Now, we need to double check this is true. Does 8, 12, and 15 add to 35? Yes, it does, so we verified that the left equals the right, and that these 3 ages, 8, 12, and 15, are the correct ages. Now, let's look at a coin problem. Very similarly, it says a cashier has 3 more dimes than nickels and twice as many nickels than quarters. Well, the one that didn't get any descriptor here was the quarters, but let's just go through here. We have dimes, nickels, and quarters. We have a descriptor for the dimes. It has 3 more dimes than nickels, twice as many nickels as quarters. So we're getting these descriptors for dimes and nickels, but nothing about quarters. So what we're going to do is assign the number of quarters as X or some variable. It could be L, M, it could be some other variable that we want to placehold here, but let's just choose X. And they say that the sum of these should be equal to $3.05 in the end. So what we're going to do is we're going to say, okay, we let X equal the quarters. Well, how many nickels do we have? Twice as many nickels as we do quarters. So it's 2 times X, or 2 times the number of quarters. And then they say there's 3 more dimes than nickels. And if there was twice as many nickels as there are quarters, then it's going to be 2X plus 3, meaning 2 times the amount of quarters plus 3, or the amount of nickels plus 3. Now we know that a nickel, quarter, and a dime have a value of a quarter is 0.25, a nickel is 0.05, and a dime is 0.10. And then we're going to multiply that to each of the X values here, or each of the numbers of quarters that are symbolic. So our number of quarters is 25 cents times the numbers of actual quarters we have. We have our nickels, which is 2X times the value of a nickel. And then we have the value of a dime times the number of dimes, and that should sum to make $3.05. We add our we add our like X terms here. So we have here, here, here. These are going to combine to make 0.55 or 55 cents. We then take our 0.3 left over and move it to the other side, giving us $2.75. And if I divide the 0.55 or 55 cents from both sides, I will get an X value of 5. Now, yet again, an X value of 5 is symbolic of the number of quarters. So we have 5 quarters total. I then want to go to my next equation and sub in that X being 5. Well, that's actually symbolic of the number of nickels, 2 times that 5. So we have 10 nickels. And then finally, I sub in the 5, which is symbolic of the number of dimes, and it's 2 times 5, which is 10 plus 3. So I have 5 quarters, 10 nickels, 13 dimes. And if I add these together, or I plug them back into my original equation, it should be that with my number of quarters and their value, my number of dimes and their value, and my number of nickels and their value, I should sum to $3.05, which in this case it would. Okay, so let's try a couple examples of our own, because those are some examples that were explained, but we want to derive our own equations from our own examples. So suppose we look at this problem here. It's a geometry problem that says a rectangle is 18 inches, or if the perimeter of a rectangle is 18 inches and one side is 1 inch longer than the other, determine how long each of the sides are. So what we're going to do is anytime they describe something geometric, let's just draw the geometric shape they're talking about. In a standard rectangle, we know that perimeter is symbolic of all the outside lengths added together, or our width. So we have a width, we have a width, we have a length, and we have a length. Now, in this case, the way they described the problem is they said the perimeter was equal to 18 inches here. So all of those lengths must add to make 18, but what I'm going to do is I'm going to try and make them all in terms of one variable so that I can solve for one variable and then get the other. What did they say in the instructions? They said that if we look at the dimensions, one side is 1 inch longer than the other, meaning my shorter end, let's call it width, is here, and then my length is the width plus 1. So we can say the length is equal to width plus 1 because they said it was 1 inch longer than the shorter side. So this is equal to W plus 1. Now let's put this in for our perimeter equation. Perimeter, which is equal to 18, is equal to 2 lengths plus 2 widths. We know with the perimeter, we now have a measure of L in terms of W. So I'm going to sub that in. 2 times W plus 1 plus 2W. I get 18 is equal to 2W plus 2 plus 2W. I'll collect my like terms on the right-hand side here and get 18 is equal to 4W plus 2. If I subtract away that 2 that's being added, I now will have 16 is equal to 4W. And therefore, if I divide away this 4 and divide away this 4 from both sides, I will get finally a W value equal to 4, or 16 divided by 4. Now, what were the units here? It's in inches, so I have to include 4 IN, or include the units at the end here. Now, remember, this is only symbolic of the width. We need the other dimension here, which is our length. So for part 2 here, what I'm going to do is just off to the side, we know that the length was equal to W plus 1. Well, we now know the width is 4, and 4 plus 1 gives us a length equal to 5. And remember, units are important here, 5 inches here. Now, we want to confirm that this is actually the solution here. So what we can do is we can go back to our perimeter equation and see if we plug in a width of 4 and a length of 5, we should get this value of 18 as the total. So our check, let's do this off to the side. 18 is equal to 2 times the length, which was 5 inches, plus 2 times the width, which was 4 inches. 18 is equal to 10 plus 8. Yes, this would be true. We do get 18 is equal to 18 for this. So we have verified that the left equals the right and that this is the appropriate equation, and we got the appropriate answers here. All right, now let's go down to some number problem. They say find a number. They're not really specific about it. This is our key word, find a number such that 5 more than 1/2 the number is 3 times the number. Okay, let's deconstruct this a little bit. We're going to assign the variable let x be the unknown number. Okay, let x be the unknown number. So now we have a variable for this unknown number. They say that the instructions should be that it's 5 more than 1/2 the number. This means what we need to do is say, okay, we have 1/2 times that missing number or the unknown number plus 5 is equal to 3 times that number, which is the unknown, or 3x. Now, my LCM here, we know that I only have one thing in the denominator, meaning I should multiply both sides by 2. If I multiply both sides by 2, well, 2 times 1/2 reduces down to 1. So we get x plus 2 times 5, which is 10, is equal to 2 times 3x is a total of 6x. What I'm going to do to isolate our x's here is I'm going to move the one with the fewer x's over to the other side. So we know that x is less than 6x. I'll move those x's over to the right-hand side. And so this is 10 is equal to 5x. The last thing I need to do here is divide away the coefficient on the x, because we know it's 5 times x. Opposite is to divide. Therefore, x is equal to 2. Okay, we need to verify that this is actually the situation or the number that would result in this equation being true. So for step 2 here, what we're going to do is verify it. So I'm going to go back to the original equation. 1/2 times 2 plus 5 should be equal to 3 times that 2. 1/2 times 2 is equal to 1 plus 5 should be equal to 3 times 2, which is 6. 6 does in fact equal 6. Yes, we have verified that the left hand equals the right hand side. Perfect. Okay, now let's look at a percentage problem here. So they say, let's consider if the price of gasoline has increased by 25% from January to March. If the price per liter was $1.10 in March, what was the price per liter in January? What are they asking for? They're actually saying that if a price increases by 25% between a certain amount of months, and that final cost after the increase was $1.10, then what was the original cost? What was the price per liter? So in class, what we actually did is we took this and we said, okay, what can we use in terms of financial terms that would describe this appropriately? Well, we can call let P be the principal amount or what we actually know from class, the original amount. And we could even call it the original price in January. Okay, we've clearly defined our variable here. Now, let's see how our equation looks. If I take P and I multiply it by some amount of percentage, we should realize that that percentage should multiply by the principal or that original amount to increase the price to $1.10. Now, 100% we know is 1. 1 over 1, that can represent 100%. As a decimal, if we take 100% and make it a decimal, we divide by the 100, we would get 1. If we do the same thing with the percentage of 25, we know 25% when divided by 100 to give us the decimal would be 0.25. So we should have P times 1.25 is equal to 1.10. And here's what I would ask you about this. If I multiply a number by something greater than 1, because we know that 1.25 is something that's greater than 1, would we see it increase or decrease? And what we'd realize is that every time we take a number that's times 1.25 or something greater than 1, we'd realize that this is going to be something that is greater than the original amount. If this was instead something that was less than 1, what we would see is that this would shrink or decrease. So logically, this should make sense that if we have something that's being multiplied by something greater than 1, it should be increasing. Now, what do we need to do here? We need to divide away the 1.25. Divide the 1.25 from both sides. When we divide the two sides by 1.25, we get P is equal to, and then in this case, we should have 0.88. And what is P actually representative of? It's the cents. So I could even throw in the symbol here. We have 88 cents is the total cost that was paid in January, or the original cost here. Now, what we could do is we could plug this back in and verify it if we go back. And so if this is step 1 is to solve the equation for the variable, and then we plug it back in, we would get 0.88 times the 1.25 should be equal to 110. If I multiply this, I would definitely see that I get $1.10, $1.10, therefore showing that the left is equal to the right-hand side. Okay, now, word problem terminology. This is where we want to go through and just say, if we look at a problem, what are they actually talking about in terms of the instructions to do with the variable? Well, first of all, if they just ask us a number, that could really be anything. It could be an X, it could be an L, it could be a P, whatever we want to assign as the number or the variable. A number tripled is similar, but we're going to write it as 3 times whatever that variable is. 3 times L, maybe 3 times P, whatever that variable is. It's the number tripled or multiplied by 3. If a number is decreased by 7, we could say it's X minus 7, or even something like Y minus 7. 3 larger than a number. Very similarly, we're going to add 3 to whatever number. Add 3 to whatever given number. 18 is increased by a number. We start with 18, and then we add some unknown quantity. Let's call it X. All right, a number is subtracted by another number. They give us a number, which is something abstract. We don't know what this number is. It's an unknown. And it's subtracted by another number. We could actually throw in another variable because they say it is a distinct another term here or another number. So I'm going to go X minus Y. 3 times a number, we've done this one before, just 3x or 3y, whatever the variable is, tripled. A number is divided by 15. This is like asking us to say we have some unknown quantity, we divide it by 15. A number is less than 12, or a number less than 12. If they ask for a number less than 12 like this, I'm thinking we need to use inequalities. Something less than 12. And then finally, this is probably the most difficult one, 3 consecutive numbers. Well, let's choose, let's say, x to represent our first number. Well, the next number after x, or whatever number we would select, would just be x plus 1. And then the number after the plus 1 case, we would just have to add another 1 or say x plus 2. Let's actually show this through a direct example here. If I choose, let's say, the number 4, well, 4 plus 1 is 5, and 4 plus 2 is 6. So now I have 3 consecutive numbers. And what I also could do is in the red, I could go in the reverse direction. I could have x minus 1, I could have x minus 2, and this would also give me 3 consecutive numbers if I looked at these. It would just be in the reverse order. I would have 4, 3, 2 as my numbers instead. So this, in future grades, you'll come to learn is also an alternative way of telling you, oh, I have 3 consecutive numbers. You can either add 1 to each of the cases, or you can subtract 1 to each of the cases. Okay, now let's try a couple examples where we have to convert things from sentences into actual equations and solve them. So let's look at the first one here. 10 less than triple a number is 20. 10 less than triple a number. Well, whatever this number is, let x be that number. Okay, so if x is this number, our first thing, they say 10 less than triple. This means I'm going to go 3x minus 10, or triple some number minus 10 must be equal to 20. If I isolate for x here, I add 10, I will get 3x is equal to 30. If I divide both sides by 3 and divide both sides by 3, I'll get x is equal to 10. Now, I could verify this is the case, that it is true, by going 2. When I plug this in, it's 3 times 10 minus 10 should be equal to 20, or 30 minus 10 should be equal to 20. Definitely 20 equals 20. And we've confirmed the left-hand side equals the right-hand side. All right, if a number is doubled, the result is 60. Simply put, the number, let's call it x. We have x times 2 is equal to 60. If I divide by 2 on both sides, this will give me a result of x being equal to 30. Now, I could plug this back into the original. I would have 2. And I have 2 times 30 should be equal to 60. Definitely 60 equals 60, and we are all complete. Left equals right. 7 plus a number is reduced by 2, and it gives you 18. So what we're going to do here is we're going to do 7 plus a number, or 7 plus an unknown x, reduced by 2, should give us 18. We combine our like terms on the left-hand side, giving me 5 plus x is equal to 18. If I subtract away the 5 and subtract away the 5, I should get x is equal to 13. Now, in step 2, we want to confirm this. We go 7 plus 13 minus 2 should be equal to 18. 7 plus 13 is 20, minus 2 is 18. So yes, we can confirm the left equals the right, and this is the correct solution. 3 times a number is 63. Well, 3 times a number, let's call that number x again. 3 times whatever that unknown number is equal to 63. Just like example 12, we're going to divide by that number. So we get an x value equal to 21, or 63 divided by 3. Now we just want to confirm that this is actually true for our equation. 3 times 21 should be equal to 63. 3 times 21 is equal to 63, so this is true. There we go. Left-hand side equals right-hand side. Okay, now we go to the next equation here. If we increase the product of 2 and a number by 4. So this is a pretty confusing and tricky wording here. I want you to really focus on it's the product of 2 and a number. Well, the product of 2 and a number is like saying it is x times 2 or 2x. And they're saying this is being increased by 4 to give us or obtain 56. When I deal with this, I'm going to subtract away the 4 from both sides here. So I'm going to subtract away 4 and subtract away 4. I get 2x is equal to 52. And if I divide the 2 coefficient and divide the 2 coefficient, I get x is equal to 26. Okay, let's confirm this is true. I go off to the side and for step 2, I want to verify it. 2 times 26 plus 4 is equal to 56. That's 2 times 26, which is 52, plus 4 should be equal to 56. Yes, 56 does equal 56, and this is totally valid. We can check that. The sum of 9 times a number and 5 is 185. So the sum, meaning that's one of our key buzzwords here, the sum of 9 times a number and 5. So what we're going to have to do is to represent 9 times a number, we could simply write it as 9x. And the sum means we're going to add 5 here is equal to 185. If I have this, I'm going to subtract away the 5 from both sides, giving me 9x is equal to 180. And if I divide both sides by 9 here and divide both sides by 9, I should get an x value equal to 20 here. Okay, let's confirm this is true. We go off to step 2 to verify. 9 times 20 plus 5 should be equal to 185. Yes, this is 180 plus 5, which is equal to 185. I definitely agree. 180 plus 5 would give us 185, which is equal to 185. And we have verified that left-hand side equals right-hand side. 17, a number divided by 6 is 21. A number, any number divided by 6 is equal to 21. Okay, if we have something in the denominator, in order to get it out of the denominator, what we're going to have to do is multiply both sides by whatever's in that denominator. So 6 is being multiplied to both sides. It will cancel it from the left here, leaving us with x is equal to 21 times 6. And 21 times 6 is 126. So when we go to our confirmation step, we're going to go 126 divided by 6 should give us 21. And we would realize, yes, 21 equals 21. Left-hand side equals right-hand side. Double a number plus 5 is 75. Well, to say double a number is to write it as 2 times that unknown quantity plus 5 should be equal to 75. If I subtract 5 from both sides, I'm going to be left with 2x is equal to 70. I divide both sides by that coefficient 2. Therefore, x should be equal to 35. For part 2, let's just double check this is the case. 2 times 35 plus 5 should equal 75. Yes, 70 plus 5 equals 75. And therefore, our left-hand side equals the right-hand side. 19, you get 10 when subtracting 16 from twice a number. They tell us the end result. They say you get 10 if you take 2 times a number and subtract 16. Well, in this case, what I'm going to do is add that 16 being subtracted to both sides. We get 26 is equal to 2x. I have a 2 being multiplied to the x, which I'll divide away, and I'll get an x value equal to 13. If we go back to our equation, we should be able to easily confirm this. For step 2 here, I get 10 should be equal to 2 times the x value 13 minus 16. 10 is equal to 26 minus 16. And yes, 10 equals 10. We have verified the left equals the right. Example 20, if a number is tripled and then reduced by 9, the result is 66. So if a number is tripled, let's call that number x. It's multiplied by 3 and then reduced, or you take away 9, the result is equal to 66. I'm going to add the 9 across and add the 9 across. We should get 3x is equal to 75. I divide by that coefficient out front to both. X will be equal to 25. Now, for step 2, we need to verify this. 3 times 25 minus 9 should be equal to 66. 75 minus 9 should equal 66. And therefore, 66 is equal to 66. And we've shown the left-hand side equals the right-hand side. All right, this is for you to check your own understanding. There is one-step word equations, and there's also two-step word equations that follow on the next page here. So you'll definitely want to try a few of each of them, if not all of them, just to make sure you're really comfortable with the ideas here.